Hello students, today I am going to introduce about the next chapter, that is p block elements. Why it is called as p block elements? In p block elements, the last electrons enters the outermost p orbital. This is called as p block elements. The number of p orbitals, that is 3, and the maximum number of electrons that can be accommodated in a set of p orbitals, that is 6. This is p orbital beta, and here 3 orbitals are present and 1 orbitals that having maximum of 2 electrons. Okay, so total number of electrons, that is 6. Okay. It is an interesting to note that the non-metals and the metalloids exist only in the p block of the periodic table. Okay. The non-metallic character of these elements decreases down the group. Now, this is position of p block element. This is p block element beta. Here 13 group is present here, 14, 15, 16, 17 and last group is 18. 18 group or 0 group or noble gases. This is 2p shell, 3p shell, 4p, 5p and 6p shell. Okay. P block elements is also called as representative elements. Okay. And in the p block, one element is here, that is helium. Its configuration is 1s2. Okay. Now, the first point, that is the general characteristics, the general electronic configuration of these elements. This is ns2 np1 1 to 6. Okay, where n is 1 to 3. Okay, except the helium atom, in which the last electrons enter in the s orbital, but it is placed with the noble gases because of the similarities in the properties of noble gases. Okay. Now, point number 2, oxidation state. Elements of p block elements of p block that shows the two type of oxidation state. First is group oxidation state and second is other oxidation state. Group oxidation state means maximum oxidation state, that is shown by the p block element, and this is equal to the number of valence electrons. Means maximum oxidation state, that is equal to ns electrons plus np electrons, where n is the outermost shell. N is outermost shell. Okay. Suppose the electronic configuration of carbon, that is equal to 6. Atomic number is 6. What is the electronic configuration of carbon? This is 1s2, 2s2 and 2p2. So these 2s2 and 2p2, these are the outermost shells, and the maximum oxidation state, that is 2 plus 2. यहाँ पे 2 plus 2. Okay, this is 4. Means the group oxidation state generally increases across a period from left to right. Okay, but other oxidation state, second type is other oxidation state. जो heavier group of each heavier members of each group that shows an oxidation state in which the 2 unit less than the group oxidation state. So this oxidation state is more stable as compared to group oxidation state. What is the reason behind this? Because the reason for the existence of this oxidation state is the involvement of ns electrons to take part in the bonding. Means ns electrons take part in the bonding. So this type of effect is called as inert pair effect. इसको क्या बोलते हैं बेटा? Inert pair effect. Okay. This effect arises because the energy required to unpair the electron. Okay. The energy required to unpair the electrons, that is more than the energy released in the formation of two additional bonds. Okay. Now, the next point is nature of element. First is electronic configuration, second is oxidation state, third point is nature of element. Elements का nature कैसा है? देखो बेटा, in this block non-metals, metals and metalloids all are present here. Okay, non-metallic character that decreases on moving down the group. The heaviest element of each group that are more metallic in nature. And metalloids are present here. This is boron, silicon, germanium, arsenic, antimony, tellurium. Okay, these are the metalloids, which shows both metallic as well as non-metallic character. Okay, now the next point is fourth point, the nature of oxide. Nature of oxides. In this case, the oxides of non-metallic that are acidic in nature, Metals are basic in nature. The acidic character of oxides decreases, but the basic character of oxides that increases on moving down a group. Okay. Now, next point number 5, formation of anion. Formation of anion. In this case, the non-metals that shows higher ionization enthalpy and higher electronegativities as compared to metals, because they have a tendency to form the anion. Okay. Now next point number 6, that is nature of compound. Nature of compound. Compound का nature कैसा रहेगा? Means when a highly reactive non-metal combines with the highly reactive metals, then it will form a ionic compound. क्या बनाता है बेटा? Ionic compound बनता है. Okay, क्यों बनता है? Because there is a large difference in the electronegativities of combining elements. Okay, but when highly reactive non-metals that react with a highly reactive non-metals के साथ react करता है, then it will form a covalent compound. क्या बनाता है बेटा? Covalent compound बनाता है because of the small difference in the electronegativities of the combining element. Okay. Now we start from group number 13, that is boron family. Okay. The elements present in this group that are boron, aluminium, gallium, indium, thallium. Okay, these are the elements present in the boron family. Okay. So boron is a non-metal, but other members of the family that shows the metallic property. The non-metallic nature of boron, that is due to the small size and high ionization enthalpy and high electronegativity. Aluminium is a metal but shows many chemical similarities to the boron. Okay. Now, what is the occurrence of boron? This is the electronic configuration, means the outer electronic configuration of these elements, that is Ns2Np1. Okay. So 3 electrons are present in the valence shell. Okay. A close look at the electronic configuration that suggests while the boron and aluminium have noble gas core, gallium and indium have noble gas plus. Now the electronic configuration of group 13 elements. देखो बेटा, boron atomic number 5, its configuration is 2s2 2p1. Aluminium, atomic number 13, its configuration is 3s2 3p2. Gallium, its atomic number is 31, its electronic configuration is 3d10 4s2 4p1. Indium, its atomic number is 49 and configuration is 4d10 5s2 5p1. Okay, so these are the electronic configuration in which the last electrons that enter in the p shell and that are having all are having 3 valence electrons. So in this electronic configuration, they suggest that the boron and aluminium that have noble gas core, and the next two member, that is gallium and indium, that have noble gas plus 10d electron core. Okay, 10d electron core, and the remaining element, that is thallium, that has noble gas plus 14f plus 10d electron core. ओके, तो बेटा जैसे जैसे हम नीचे जाते जाएंगे डी ब्लॉक्स आते जाएंगे एंड एफ ब्लॉक्स भी आते जाएंगे. ओके, द इनर कोर दैट मेक द केमिस्ट्री ऑफ दीज एलिमेंट्स दैट आर मोर complex as compared to the elements of S block element. Okay, now what is the occurrence? Boron is a rare element and that constitute 0.0001% by the mass of earth crust. It is present in two isotropic form, that is B10 and B11. Okay, now boron is present in the form of borax, means orthoboric acid. ऑर्थोबोरिक एसिड का फॉर्मूला क्या है बेटा? H3BO3. ऑर्थोबोरिक एसिड H3BO3. ओके, नेक्स्ट बोरेक्स. बोरेक्स जो इसका नाम है, बोरेक्स का बेटा ये फॉर्मूला है Na2B4O7 इंटू में 10H2. ओके, नेक्स्ट इज कर्नाइट. कर्नाइट का क्या फॉर्मूला है? Na2B4O7 इंटू 4H2. ओके, इन इंडिया बोरेक्स अकर इन पुगा वैली, दैट इज लद्दाख, एंड संबर लेक, दैट इज राजस्थान. ओके, now aluminium is most abundant element and the third most abundant element in the earth crust after oxygen and silicon. बॉक्साइट. बॉक्साइट क्या है बेटा? ओर्स, जहाँ से एल्यूमिनियम को निकाला जाता है, एक्सट्रैक्ट किया जाता है. इट्स फॉर्मूला इज Al2O3 इंटू 2H2. एंड क्रायोलाइट. क्रायोलाइट का फॉर्मूला क्या है? Na3Al(F6). दैट आर द मोस्ट इंपॉर्टेंट मिनरल्स ऑफ एल्यूमिनियम. ओके, इन इंडिया इट इज फाउंड एज मिका. मिका क्या होता है बेटा? KAl2Si3O10. ओके, एंड OH का वोल्टवाइज. इट इज फाउंड इन MP, कर्नाटका, उड़ीसा एंड जम्मू. ओके, नाउ next are the variation in properties. As we have already discussed about the electronic configuration, and the second is atomic radii. देखो बेटा क्या है? The atomic radii and ionic radii of the element of group 13 that are smaller as compared to the element of group 2 elements. ओके, क्यों बेटा स्मॉलर क्यों होती है? बिकॉज ड्यू टू इंक्रीज इन द इफेक्टिव न्यूक्लियर चार्ज. ओके, on moving down the group, the successive elements, one extra shell is added, so the atomic radius is expected to increase. Means on moving down the group, the atomic radii increases because the successive addition of one extra shell of the electrons. Okay, but one may notice a division, atomic radii of gallium, that is less than the aluminium. ओके अब रीज़न क्या है इसका, व्हाट इज़ द रीजन बिहाइंड दिस कि एटॉमिक रेडियाई गैलियम की लेस होती है, इसकी 135 पिकोमीटर होती है जबकि एल्यूमिनियम की 143 पिकोमीटर है। तो क्यों है, जबकि हम नीचे जाते हैं तो हमारी एटॉमिक रेडियस बढ़नी चाहिए, ठीक है। पहले बोरोन आता है, फिर एल्यूमिनियम आता है, फिर गैलियम आता है, फिर इंडियम आता है। तो गैलियम की जो है लेस है एज़ कम्पेयर टू एल्यूमिनियम, जबकि इंक्रीज़ होनी चाहिए। तो रीज़न क्या है बेटा इसमें, बिकॉज गैलियम की जो कॉन्फ़िगरेशन होती है वो क्या होती है 3d10। यहाँ जो कॉन्फ़िगरेशन है मैं लिखती हूँ अभी, जो गैलियम की कॉन्फ़िगरेशन है दैट इज़ 3d10, ओके, 4s2 एंड 4p1 ये होती है बेटा, ओके। तो इसमें क्या होता है बेटा हमारे पास कि एक्स्ट्रा 10d इलेक्ट्रॉन्स आ जाते हैं। Extra 10d electrons present in gallium atom does not screen the nucleus effectively, ठीक है। So the electrons of gallium that are attracted more by the nucleus, so its distance from the nucleus and the outermost electrons that is small, so atomic radii decreases, okay, this is the exact reason. Now, next is ionization enthalpy. It is denoted by IE or delta H. The ionization enthalpy that shows the irregular trends. Means इसमें क्या होता है बेटा, जब हम बोरोन से एल्यूमिनियम की तरफ जाते हैं तो इसकी आयनाइजेशन एंथैल्पी क्या होती है, डिक्रीज होती है बेटा, ओके। और जब हम एल्यूमिनियम से गैलियम की तरफ जाते हैं बेटा तो इट इंक्रीजेस, फिर ये इंक्रीज होती है। फिर गैलियम से बेटा किसकी तरफ जाओगे आप, इंडियम और थैलियम की तरफ, तो ये फिर डिक्रीज होती है। इंडियम से थैलियम की तरफ जाओगे बेटा फिर से इंक्रीज हो जाएगी, ठीक है। मीन्स एक बार डिक्रीज फिर इंक्रीज फिर डिक्रीज फिर इंक्रीज ऐसे हो रहा है। मीन्स द आयनाइजेशन एनर्जी ऑफ बोरोन दैट इज हाईएस्ट इन द ग्रुप because atomic size is smallest and the shielding effect is lowest. So due to the shielding effect, the sharp decrease from boron to aluminium. Okay, क्यों होता है बेटा, due to increase in atomic size and the shielding effect of S and P electrons of outermost energy shell. Okay, but in case of gallium there is d10 electrons in the outermost shell which shield the nuclear charge less effectively, so that the outer electrons is held by the nucleus. So the ionization energy that remains same as that of aluminium, okay, so atomic size increases. But in case of indium, the number of d electrons and their shielding effect remains same. So the ionization energy decreases in indium due to increase in the atomic size from gallium to indium. Okay. Now the increase in the ionization energy from indium to thallium, this is because the nuclear charge increases by the 32 units, okay, which outweigh the shielding effect of all the electrons of inner shell including 14f and 5d electrons. इसमें बेटा f भी आ जाते हैं और d भी, दोनों ही इलेक्ट्रॉन्स इन्वॉल्व होते हैं, ओके। सो इट्स आयनाइजेशन एनर्जी increases, okay. Now the first ionization energy of these elements किस ऑर्डर में होती है बेटा, देखो ये आपकी फर्स्ट होगी, स्मॉल होती है एज कंपेयर टू सेकेंड और एज कंपेयर टू थर्ड, मीन्स थर्ड की सबसे हाईएस्ट होगी। मीन्स द टोटल ऑफ 3 successive ionization energy that is very high because these elements have very little tendency to form the trivalent ions, okay. So in this case boron do not form B3 पॉजिटिव आयंस। अब एक क्वेश्चन यहीं से आता है कि बोरोन B+3 आयंस नहीं बनाता, because the sum of first three ionization energy in case of borons is very large. Then the small atom of boron that is not able to accommodate that energy. Okay, so in case of aluminium, aluminium Al+3 बनाता है जबकि बोरोन नहीं बनाता. In case of aluminium, the sum of first three ionization energy decreases. So it is able to form Al+3 ions. Okay. Now, what do you mean by inert pair effect? It is the phenomena of electrons remaining paired in the valence shell. This is called as inert pair effect. Means it is the reluctance of the s electrons of valence shell to take part in the bonding. It occurs due to the poor or ineffective shielding of ns2 electrons of valence shell by intervening d and f electrons. d and f electrons के बीच में आने से बेटा जो इसकी ns2 electrons की shielding होती है वो क्या हो जाती है, poor हो जाती है. ठीक है, तो इसी को हम क्या बोलते हैं, इनर्ट पेयर इफेक्ट बोलते हैं. It increases down the group and lower elements of this group that shows the lower oxidation state. Okay, this is called as inert pair effect. Now, oxidation state. Boron and aluminium both shows +3 oxidation state, while rest gallium, indium and thallium that shows oxidation state of both +1 and +3. देखो बेटा इसमें क्या रीजन रहेगा आपका कि भाई बोरोन तो सिर्फ +3 ऑक्सीडेशन स्टेट शो करते हैं जबकि अदर एलिमेंट्स +1 और +3 दोनों ही शो करते हैं. तो इसमें रीजन क्या रहेगा, देखो द +1 ऑक्सीडेशन स्टेट बिकम मोर एंड मोर स्टेबल एज वी मूव डाउन द ग्रुप. जैसे जैसे हम नीचे जाते हैं वैसे +1 ऑक्सीडेशन स्टेट क्या होती है, ज़्यादा स्टेबल होती है. ओके, इन दिस केस एल्यूमिनियम, gallium, indium and thallium means thallium shows +1 oxidation state जो कि सबसे ज़्यादा स्टेबल होती है, फिर इंडियम, फिर गैलियम एंड फिर एल्यूमिनियम. तो व्हाट इज़ द रीजन बिहाइंड दिस? दिस इज़ द बिकॉज ऑफ द प्रेजेंस ऑफ intervening d and f orbitals which don't shield the nucleus effectively. Okay, if the effective nuclear charge increases, that holds the ns electrons more tightly so that they don't participate in the bonding. तो ये ns इलेक्ट्रॉन्स को ज़्यादा टाइटली बाउंड कर देगा और ताकि ये बॉन्डिंग में पार्टिसिपेट ना कर पाए. सो दिस इफेक्ट इज कॉल्ड एज इनर्ट पेयर effect. Okay, so as we move down the group, in the group 13 elements, due to inert pair effect, the tendency to shows the +3 oxidation state decreases and the tendency to attain +1 oxidation state increases. Okay, so in case of thallium, thallium shows +1 oxidation state that is more predominant as compared to +3 oxidation state. Okay, the compounds in +1 oxidation state that are more ionic as compared to +3 oxidation state. Now next is Lewis acid. Boron trifluoride is a trivalent molecule of boron and the number of electrons around the central boron atom in this molecule that is 6. It has incomplete octet. Octet means 8 electrons. So this is the electron deficient molecules and it has a tendency to accept the lone pair of electrons to achieve the stable inert gas electronic configuration. So it behaves as a Lewis acid. Okay. The Lewis acid character of trihalides of group 13 elements means these trihalides are Lewis acids, means these are electron deficient. These are electron deficient. So they have a tendency to accept the electron pair. So the electron accepting tendency of trihalides that are in this order. First is boron, after that aluminium, then gallium and indium. Okay. The relative strength of trihalides of boron that act as a Lewis acid. This is determined by measuring their heat of formation as well as by the infrared spectra. So the order will be BBr3, BCl3, after that BF3, because of the electronegativity of the halogen group. Okay. So the Lewis acid character of trihalides that can be explained on the basis of tendency of halogen atoms to back donate its one pair of electrons to the boron atom. This is fluorine atom, and this having a lobes of electrons. This is boron atom, and this will form one fluorine here, and this fluorine atom here. So this is filled orbit. In case of BF3 molecules, the 2p orbital of each fluorine atoms that are fully filled. This is fully filled. One of the 2p orbitals of boron, this is vacant. This orbital is vacant. So an additional p pi bonding is established between these 2p orbitals of same energy due to the partial transference of electronic character from fully filled orbitals to the vacant orbital. Okay, this one. The BF bond acquires some double bond character. So this type of bonding, this is called as the back bonding. Okay, इसको हम क्या बोलेंगे बेटा, back bonding बोलेंगे. The back donation of electrons from fluorine to boron, the electron deficiency of boron atom that get compensated, and it will shows the decrease in the Lewis acid character. So this tendency to form a back bond is maximum in case of BF3, and that falls rapidly as we move from BF to BCl3 to BBr3. Okay, because the energy difference between fully filled orbital of halogen, this is Cl के अंदर कौन सा fully filled होता है 3p, and Br that is 4p, and the vacant orbital of boron that is 2p increases. It means वहाँ पे जो energy difference होता है बेटा, जो फुल्ली फिल्ड ऑर्बिटल्स हैं हैलोजेंस के और जो वेकेंट ऑर्बिटल है बोरॉन का, उनका एनर्जी डिफरेंस इंक्रीज हो जाता है, जिसकी वजह से जो बैक बॉन्डिंग होती है वो BF3 में मैक्सिमम होती है, एंड आफ्टर दैट इट विल बी डिक्रीजेस. ओके, सो ड्यू टू दिस बैक बॉन्डिंग इट्स Lewis acid strength that is BBr3, after that BCl3, and after that BF3. बैक बॉन्डिंग इसके अंदर इंक्रीज होती है, Lewis acid स्ट्रेंथ सबसे ज़्यादा इसमें होती है. ओके, नाउ नेक्स्ट इज केमिकल रिएक्टिविटी. Action of air, oxygen, amorphous boron on heating in air, it will form B2O3. Means 4 boron plus 3 O2, it will form B2O3, boron trioxide. रिएक्टिविटी टुवार्ड्स हैलोजेंस, मीन्स बोरोन जब रिएक्ट करता है बेटा क्लोरीन के साथ तो BCl3 बनाएगा, मीन्स ट्राई हैलाइड्स बनाएगा. नेक्स्ट है बेटा रिएक्टिविटी टुवार्ड्स वाटर. वाटर की टुवार्ड्स रिएक्टिविटी क्या है, देखो. प्योर बोरोन डज नॉट रिएक्ट विद वाटर. एल्यूमिनियम डिकम्पोजेस बॉइलिंग वाटर एंड दैट इवॉल्व्स द हाइड्रोजन गैस. एल्यूमिनियम जब वाटर के साथ रिएक्ट करता है तो एल्यूमिनियम हाइड्रोक्साइड बनाता है. ओके, Gallium and indium are not attacked by pure cold or hot water. Thallium is a little more attractive than the gallium. Okay. क्यों होता है बेटा ऐसे कि जो एल्यूमिनियम हाइड्रोक्साइड है और गैलियम हाइड्रोक्साइड है दैट आर एम्फोटेरिक, बट इंडियम हाइड्रोक्साइड और थैलियम हाइड्रोक्साइड दैट आर बेसिक इन नेचर। ठीक है, तो इसकी जो बेसिसिटी होती है वो, जैसे कोई भी मेटल है यहाँ पे और ये आपका हाइड्रोक्साइड बनाता है, तो इसकी जो बेसिसिटी होती है इंक्रीज होती है। क्यों बेटा? क्योंकि साइज ऑफ द आयंस इंक्रीजेस, सो द टेंडेंसी टू रिपप्चर द OH bond decreases, so the acidic nature decreases but basic nature increases। ओके, तो बेसिसिटी यहाँ इंक्रीज हो जाती है।